Hi everyone and welcome to my channel. I'm Eugene and this channel is dedicated to teaching of programming and software development. In the previous lessons, we learned about variables, data types, as well as how to print to the console and read data from the console. This is the fifth Programming Fundamentals lesson, and in this lesson we are going to learn about arithmetic operators. Arithmetic operators allow us to perform calculations with numeric types. However, we'll see later that there are operators that can be used with other types as well. Now, there are two types of operators that we'll learn about. Basic operators that work on two operands, for example, plus like in 5 plus 3, or multiplication like 2 multiplied by 4. And there are unary operators that work on a single operand. And even though a unary operator looks strange in the beginning, it is very convenient and used very often. Let's start with basic operators that we have in C#. First, there is the addition operator that adds two numbers. In this case, the result variable will be assigned with 8. We have the subtraction operator and multiplication. These operators work very similar to what we are used to in math. In addition, there are two more operators that maybe need a little more attention. The first one is division. It works on two operands like the previous operators, but let's think of what the result should be. Since we are dividing integers, the result will also be an integer. And in this case, if we divide 5 by 2, the result will be 2 and some remainder. So the result variable will get the whole part of the division, which will be 2 in this case. And this brings us to the next operator named modulo, which in the same example returns the remainder of the integer division. So in this case, the remainder variable will be assigned with 1. Pay attention that this works with integer variables. If one of the operands is a floating point variable, the result will be a floating point number. Now consider that we have a variable named a that had a value, and we want to add 5 to that variable. In such a case, we would do the following. A equals a plus 5. As you can see, we have the same variable twice, so there is a shortcut for this kind of operations, which is simply writing plus equals. This is the same as to take the value of a, add 5, and then assign the result to a. And this type of operators exist for addition, subtraction, multiplication, division, and modulo. In addition to the operators we've just seen, there are unary operators that work on a single operand. To start with, let's look at the following two operators that are very simple but still operators, and I would like to mention them. The first one is plus, which actually doesn't change the value of its argument. So in this case, plus 5 is simply 5. The second one is minus, which means negation. In other words, it takes the argument and returns the negative value of the number. In the case of the second example, a will be minus 5. Now, let's look at some special unary operators. As we've seen, if we want to add a number to the same variable, we can use plus equals. Now, what if we want to add 1? For adding 1 to a variable, there is another shortcut, which is plus plus. A plus plus means add 1. So in the example that you see, after doing a plus plus, the value of a will be 6. The same works for subtracting 1 with minus minus. But plus plus and minus minus are not just shortcuts. You can place these two operators before the variable or after it, postfix or prefix. When the operator is used as a prefix, the variable first is changed and then the result is returned. In the case of the example, b will be 6 when we use the prefix version of plus plus. If the operator is used as a postfix, the current value is first used and then the variable is changed. In the example, you see b will be 5, while a will be incremented to 6. Now, let's say a few words about precedence. Just like in math, multiplication, division, and modulo are calculated before addition and subtraction, and parentheses have a higher precedence. Okay, now let's go to VS Code, where we'll see some examples as well as a few important points that I didn't mention in the theoretical part. Alright, now we are in VS Code and I already have a console app. And the first thing that we are going to try is basic arithmetic operators. So let's do the following. Let's type int result equals 5 plus 3. Yes, this is very simple, but let's try it. And now let's print the result. Now you remember I told you that some operators have different uses. So actually plus can be used not only with numbers, but with strings as well. And what plus does for strings is concatenation, which means that it will add the string representation of result to the string here. All right, now let's run this. All right, so as expected, the result is 8. Now let's quickly see minus and multiplication. Let's comment out that line. All right. The result is 2, as expected. Okay. Now let's try multiplication. All right. So as you can see, the result is 15. Okay, very good. Now let's do something different. Now let's see how division works. So first, let's do the following. Let's divide 5 by 2. And let's see what the result will be. All right, so as you can see, the result is 2 and not 2.5. simply because we have an integer division here, which means that we are dividing an integer number by an integer number, and the result is an integer as well. So in this case, if we have an integer division, so the result will contain the whole part of the division. Now, if we want to get the remainder of the division, we are going to do the following. Int remainder 5 modulo 2. All right, now let's print the remainder as well. Remainder. Okay. And as you can see, the result is 2, while the remainder is 1. Now, what if we want to do a floating point division, which means that I don't want to get the result as a whole number and the remainder, but I'd like to get the result just as we are used to. For example, in this case, I'd like to get 2.5. Now, let's try to do it. First, I'll comment out what we've written, and let's do the following. So we want the result to be a double. So I'm going to create a double variable, and then let's do the following calculation. Let's do, for example, 12 divided by 4. And then we'll print the result. All right, so as you can see, the result is 3, but this was easy because it's actually, the result is a whole number anyway. Now, what if instead of dividing by 4, we would divide by 5? So let's see what the result will be then. If we run it, you'll see that the result is 2, even though the variable we declared for the result is of type double. And why this is happening? This is happening because when we divide an integer number by an integer number, the result will always be an integer. And in this case, what's happening is that first we get an integer division, so the result of the integer division is 2, and then this integer 2 is assigned to the double result. And it can be easily assigned because double actually can contain any integer number. So we can implicitly convert those types from integer to double. If we actually want to do the calculation, as we said, to get a result, a floating point number result, we need at least one of the operands to be of type double. So this can be easily solved by, for example, saying that this 12 is not an integer, but a double. We already saw this. This is called casting. And what we do right now, we cast 12. Actually, we say that its type is not an integer, but it's a double. And now, when one of the operands is a double, we'll see what the result will be. Now, as you can see, the result is 2.4. Now, if we are talking about division, I'd like to mention one more thing here. Just like in math, dividing by 0 is illegal. So if I'm doing something like this, 12 divided by 0, you will see that we have an error. So we even see it during development. Now, what if we, for example, assign 0 to a variable? So the compiler can't know in advance that this is a 0. For example, let's define a variable like int 0 equals 0, and then we'll put the 0 variable here. Now the compiler doesn't know that 0 is going to be 0 in runtime. So we can compile the program and try running it. But then you will see that we get an error or an exception during runtime which says attempted to divide by 0. So this is something that we need to know. Now, as you remember from the theoretical part, there are more operators. And now let's see the shortcuts that we've seen before. So I'm going to comment out this as well. And now let's see the following. I'm defining a variable a that will be assigned with 5. And then I'm going to do the following. I want to add 2 to the variable a. So we can do it like this. A equals a plus 2. And then let's print a. All right. So a is 7, which is expected actually. And now let's see. So instead of typing it like this, we can simply type a plus equals 2. So as you can see, it's both shorter and we don't need to duplicate the variable name. All right, now if we run this again, we will get the same result. And as I said, this works for plus, for minus. We can also multiply like this, divide, and perform the modulo operation. All right. Now, what if we did the following? Instead of adding 2, I want to add 1. So in this case, we are going to see that a will be 6. Now, as I said, there are unary operators that are even shorter than these shortcuts. And instead of doing a plus equals 1, we can simply type a plus plus, which is equivalent to a equals a plus 1. There is something additional in this operator, but from this point of view, this is equivalent. Now, if we run this, we will see that a is again 6. So actually 1 was added to a. The same works with minus minus. So this time a instead of 6 will be 4 because we subtracted 1 from a. And now let's see the difference between prefix and suffix. So let's do the following. First, we assigned 5 to A. Now let's return it to how it was, A++. All right. Now, instead of just printing A, let's do the following. Let's declare a new variable B and assign the result to B. And then let's print B. Now, what do you think is going to happen in this case? So, in this case, we are going to get the following. As I told you, A++ does two things. It both returns the result. We'll talk in a second about which result exactly will be returned, and it increments the variable. So in this case, A will be incremented anyway, and let's print it and show it. Right? So let's print both A and B. All right. So A will be incremented, but B will get the result before the addition of 1. As you can see, the plus plus stays after the variable, which means it's a postfix. So it will be incremented after returning the value of A. Now, let's run this and see what's happening. So as you can see, A is incremented, so the result, so A is 6, while B was assigned with the value of A before the addition. All right, now let's do plus plus, but when it's as a prefix. And this time, what we expect to happen, we expect A to be incremented, but we also expect B to get the result after A was incremented. So first increment, then return the value. And as you can see, in this case, both A and B are 6, because first A was incremented to 6, and we see the result here. And then the value of the new A was assigned to B. So B is 6 as well. This was an important lesson in which we learned about arithmetic operators. Thank you for watching, and see you in the next lesson.